The arithmetical systems and computers are the human inventions to determine luck, existence, or future. By studying the past through billions of examples, we speculate about the future. Knowledge is power, but it is also overwhelming and comes with a great responsibility. That is why we need machines. Machines that can learn from examples and are using immense processing power to help us in discovering patterns and predict the future. Today we will talk about machine learning and artificial intelligence. Welcome to LP Tele. As we said in a previous video, big data are two words that we hear a lot today. And by their 5 V's, we understand why it is an obstacle that we need to handle before we take decisions. The link of the previous video about the 5 V's of big data is in the description of this video. The internet is itself a revolution that came with a price. Having all of this information, data and examples that are generated every second, we cannot ignore them if we want to take smart decisions. This demands the use of techniques that cope with these massively generated datasets, and this is where machine learning and artificial intelligence come as a revolution, as a groundbreaking way of handling the existing information to produce new one. Machine learning is nothing more than algorithms that deal with big data, learn from it, and reveal hidden insights. The way they are learning from thousands of examples is called training, where you feed your algorithm with many questions and answers. As a result, we are left with a system that requires us to ask questions similar to the ones used in the training, in order to produce an answer. For example, what Google did using the processing power of 10,000 computers. Gave to the system millions of pictures of animals and their names in labels. To cat pictures, gave the name cat. It is pretty much the way we learn through examples. Now, a baby or a system that has seen many photos of cats can answer the question, what animal is this, when a picture of a cat is shown to it. The part where we are learning through examples is where an algorithm is trained, as it is called. During the training, the different parameters of the algorithm change in order to give to a specific input the desired correct output. We will talk more about what parameters are in a future video, but for now you can think of them as the variables that are taken under consideration with the input during the calculation of the output. So if the input is a small mammal with 4 legs and a long tail, delicate fur and lives in the cities, then the corresponding output could be cat. During training, both input and output are given to the algorithm, and the only thing that changes is the algorithm's parameters. After training, our machine is ready for testing. During testing, we do not give a pair of input and output, but we give half of the example, only the input, and we want to see if our machine, using the trained parameters, returned to us the correct answer, which is the other half of the example, and this is the output. So imagine that our data are thousands of examples. Each example is a pair of input and output, such as the given one before with a cat. Now we keep some of these examples, usually the majority of them, something like 90% of them, for training, and the rest, 10%, is used for testing. This is called dataset split, and the examples that are used for training will teach our model how to behave by adjusting its parameters to the given examples in order to produce the correct output. The examples that are used for testing will check by using the half example only the input. If the algorithm correctly predicts the answer by comparing the produced by the algorithm predicted output to the real one, which is the other half of the example. So if the example that I gave before was used for testing, then the procedure would be like this. The algorithm would see only the input, which is a small mammal with 4 legs and a long tail, delicate fur, and lives in the cities, and would predict a label for it. Let's say that this label is dog. Now we compare this prediction to the real output of this particular example, which is the label cat. The predicted and the real value do not match, which means that our algorithm is not accurate. Accuracy is an important metric when we measure an algorithm's performance. Let's say that we tested our trained algorithm on 100 examples, and the predicted value was equal to the real one 90 times, while 10 times it wasn't. We would say that this algorithm is 90% accurate. If this is a high accuracy or not depends on what task we want to achieve. For example, for a machine that predicts the weather, probably it is a very high one, as predicting accurately 9 out of 10 times the weather is okay. On the other hand, if we had a machine that is used in piloting an airplane and it is predicting the distance from the ground in order to land it, then a 90% accuracy is very low because it would have catastrophic results. We will see more analytically in a future video how machine learning works and the different types of data that we can use, questions that we can answer, and types of problems that we can solve. For now, I would just like to explain to you a few terms about training, testing, predicting, and give a broader idea about why this process is called machine learning and how we train our machines through examples to react and replay questions based on what they have learned. So, now, when you hear artificial intelligence, you know why it doesn't work with out-of-box thinking, and it is impossible for a system to improvise or act differently than it has been trained to. The artificial intelligence, AI, that you see in movies is nothing but an algorithm with parameters adjusted to a specific type of problem. It is brilliant because using brute force power, it processes thousands of examples, keeps this information in a few parameters, and after testing, it is ready to be used for predictions. This process is empirical to humans, time-consuming and impossible in cases where you have to take under consideration something like 400 variables to answer a single question. Also, the answer is not biased if the way the algorithm was built is not biased, which means that we have to spend significant time building and testing, but after we have a handy calculator that takes input and returns output in milliseconds. The challenge here is that even though we have some algorithms for some types of problems, each specific case is unique, has different examples, and will lead to a different trained and ready-to-be-used system. The best thing is that machine learning techniques handle big data. So now you know that with all this data out there, there are so many domains, types of problems, and distinct cases where machine learning techniques can lead to insights revealing, predicting modeling, detection of triggers, and so much more. In fact, the opportunities and amount of work to be done as big data grow and everyone wants a piece of information, predictions, help in decision making, and cutting-edge technological miracles, that the demand for data scientists led to machines that train machines like a human would do. But we will see more about this in a future video. Till then, stay curious and accept challenges. Bye!